Hi everyone, I'm Junaid Mustafa, third year undergraduate student of the Department of Mechanical Engineering in IIT Kharagpur. Here's my roll number 21ME30060. Now I'm going to present my assignment 5, which is the final project of Mechanism Sessional course for the academic year 2023 to 2024. Here, from the given problem statements, I chose dumper truck rear door opening mechanism. In this problem statement, it's given that generally dumper trucks have gravity driven rear doors and a manual lock. Our aim is to mechanize the rear door opening so that it opens as the bin tilts. Also, you can add any innovative ideas like increasing door opening angle and a self-locking system, etc. So let's begin with it. In general, dumper truck bins have dimensions 4 into 2.5 into 2 meter cube, which is length into breadth into height. And the maximum bin tilt angle usually in the range 45 to 60 degrees. So I used similar dimensions and range while creating my model. Here's the model of dumper truck I created using SolidWorks software. Here I have improved door tilt angle and also added a self-locking and release mechanism. Let's see these mechanisms one by one. The mechanism which you are seeing here is the opening mechanism. It is a simple 4-bar mechanism. The shortest link with length 48.78 units acting as a coupler, and this is the ground link with length 87.19 units. Also, the length of this link is 200 units and this link length is 231.78 units. Now, as you can see, the rear door opens automatically with the bin tilt, but there are some issues with this mechanism, like the maximum tilt angle is approximately just 41 degrees and even the door is not opening completely, just until 77 degrees approximately. So I tried improvising this mechanism by correcting these issues. Here is the improvised opening mechanism with shortest link 48 units, ground 111.8 units, longest link 260 units, and the other link 200.25 units. So here you can see rear door opens when bin tilts, and here the maximum tilt it can achieve is approximately 57 degrees, and also the door opens completely, which is above 100 degrees. So this is the opening mechanism that I have shown earlier, and I added it to my final model. And here you can see one more mechanism in this model. It is locking and release mechanism, which can release the bin when it is about to tilt and lock when bin comes to its initial position. I slightly tweaked this link in opening mechanism just to avoid any collisions with the locking mechanism. Now let's see how I synthesized this locking mechanism. The base of this locking mechanism is 4-bar mechanism. This is the ground link and this is the input link and this is the output link. The idea which led to the synthesis of this mechanism is when the input link rotates an angle theta, then the output link should have rotated 2 theta in the same direction. As you can see, the output link is rotating with almost twice as fast as input link. Now, to implement this mechanism in my model, I had to extend this mechanism with two more links, making this a 6-bar mechanism. And this is how I made it. Now, let me show me how all these mechanisms sync with each other by simulating this model. Here, I'm going to assume that bin is going to tilt with some constant angular velocity. Now, you have seen this opening mechanism. Let me show the locking mechanism from close. So that's how it is. Also, here's the plot of functional relation between bin tilt angle and door opening angle. Here on y-axis we have bin door opening angle with respect to bin, and on x-axis we have bin tilt angle. As you can see, the values on x-axis vary from 0 to 55 degrees, which means this is the range of bin tilt. And on y-axis you can see the values varying from 90 to minus 30. So here actually the door is initially is 90 degrees with respect to bin base, and it rotated around till it reached minus 13 degrees, which is almost 103 degrees. So this graph or plot denotes the functional relation between bin tilt angle and door opening angle. In this plot, you can see the angular velocities of both door opening and bin tilt. Here, the red line denotes the angular velocity of bin tilt. As I said, it is constant, and the blue plot denotes the angular velocity of door. And at last, this is the plot of angular velocity of bin tilt and the angular velocity of lock. How the locking link is rotating with respect to the bin tilt. So you can see the red graph denotes the locking link angular velocity, and blue line denotes bin tilt angular velocity. That covers all the points and simulation synthesis to be shown according to the problem statement. It's the end of the video. Thanks for watching.